That's how you can be able to find the surface area of a closed cylinder. What about an open cylinder? What about an open cylinder? New share. Now, open cylinder, open. The cylinder can be open on one side, or both sides. It can be open on one side or on both sides. This one is on, this one is zero. On one side or on both sides. So if it is open on one side, how do you find its surface area? If it's open on one side, how do you find its surface area? So the meaning, if it is open on one side, there is only one circle. So you're only going to use pi r squared, because you're not going now to have the two. Pi r squared. You're not going to have now the two areas, areas of the circle. Okay, so you're only going to have that, and then you see now plus the curved surface area. So it is the area of one circle plus the curved surface area, and you know that to find the curved surface area, you just require to use this formula here. Yeah, this is the formula of it. Into brackets, you can put this one. So this is how you're going to find that one. So you have the area of one circle, or you can call it the circular part. So you have one circular part, which is found by pi r squared which is going to be found by is going to be pi r. So one for the area of cylinder which is open on one side. So you have one circular part which is found by pi r squared plus the curved surface area is going to still to remain 2 pi r h. Yeah, and then the other scenario is open on both sides. Open on both sides. If it is open on both sides, it means there is no circular bottom. There are no circular parts there. There are no circular parts. There are no circular parts. So what you're going to have is only the curved surface area. You're only going to have the curved surface area, and you know the curved surface area. This is how you find. This is how you find the curved surface area. So that's how you would have. So this is how you would find the surface area of a cylinder. Closed on both sides, you have said if it is closed on both sides, it is closed. This is how you're going to use it. 2 pi r h plus pi r squared. Okay. If it is open on one side, you have pi r squared plus 2 pi r h. That's the curved surface area. Open on both sides, there are no circular parts, so you're only going to have the curved surface area. So let me now come to the other parts so that we can finish up with the cylinder. Volume of a cylinder. Volume of a cylinder. How do you find the volume of a cylinder? So the volume of a cylinder, volume is the contents or the amount of maybe water or something else. The content that can fit in that cylinder. The content that can fit in that cylinder. So the formula is, when you're looking at the cylinder, base area times, insert the formula, insert the symbol, sorry, times the height. Base area times the height. When you look at the shape of a cylinder, what is the shape of the base? The shape of the base is circular. So how do you find the shape of a circular item? You do this one by saying pi r squared. So let me copy this. Okay. So so by this. And then you multiply by the height. Multiply by the height. So what is our radius? Our radius, we said, remember we said that our radius was, if you come here, our radius was 5 centimeters and our height was 10 centimeters. So we are going to have, actually what we are going to have here in this formula, we are going to have pi times pi times radius, which was 5, so 5 squared. So I come here and I make this one square. Okay. I remove this one. And then I now see times the height. I insert. Let's go again. Times the height. So we have pi times 5 square times the height. Remember we said the height was how many? The height was 10 centimeters. So the height is 10. So the height is 10. So what is going to be the answer? So I share now the calculator. So we come here to the calculator. So we have 5. So you have pi. So we come here to pi. So we see pi times 5 squared times 10. And the answer is, that's the answer here. So we copy the answer and then we bring it here. We bring our answer here. So let's have our answer down here because you can see it's a big answer. So this one is centimeters cubed or cubic centimeters. I will explain why it is cubic centimeters. So the answer in 4 significant figures, 1, 2, 3, 4, and then we consider the 5th significant figure. So these other numbers here, we don't require them as such. So we remove them. Yeah. See this one well. So 785.39 centimeters cubed or cubic centimeters. So significant figures, 1 significant figures, 2, 3, 4. We consider the 5th significant figure here, which is 9. So this, we now round off the, instead of having the 3, we have the 4. Yeah. Why do we have cubic centimeters? The reason why we have cubic centimeters here is because, as you can see, we are talking about 3 units. Base area. Area is found in centimeters squared, and then we have the height. So it's like we are saying here, the first part here, because area is going to be found in centimeters squared, and then we are going again to multiply by centimeters. Yeah. So you see centimeters squared plus centimeters becomes centimeters cubed. That's why area is found in cubic units. And in this case, because we are using centimeters, the volume is going to be found in cubic centimeters. So the volume of a cylinder, to find the volume of a cylinder, we say base area times the height, which is pi r squared h. That is the final formula of finding the volume of cylinder. That's the final volume of finding the volume of a cylinder. So let me come back to you now so that we can see. Joyce Otieno, Bona Jaguar muted. Joyce? Joyce? Joyce?
Yeah.
How are you doing?
Yeah.
Do you have a pen and a place to write? Yes?
Yes, I am.
Okay, so can you find the volume of a cylinder? Joyce? Joyce?
Yes.
Calculate the volume of a cylinder. that is radius 7 centimeters. Have you gotten that?
7 centimeter.
Radius 7 centimeters and height 12 centimeters. And height 12 centimeters. And then you can give us the answer. Hapo kwa chart, you can write the answer. Hapo pale kwa chart. So I will confirm that answer with you. Caroline. Kialo? Caroline? Can you hear me?
Sir?
Yes?
Yes.
Can you
Yeah.
yes, can you calculate the volume of a cylinder? Are you hearing me?
Yes.
Volume of a cylinder, radius 3 centimeters and height 12 centimeters. Radius 3 centimeters and 12 height centimeters. And then you give us our answer pale kwa chat. So ladies and gentlemen, we now go to the next solid. The next solid. Now, please remember, if you have a question, you can chat. Yeah, there's chat here. Hi. So if there's a place where we have a group chat, so we can be able to see, for example, I've asked you, I've told you hi, please ask the question here. So if you have a question, chat, and all of us are going to see. So Caroline and her friend, they are doing something. Yeah, Caroline and her friends are doing something. So it's good. It's good that we are able to do that. So let me have this one as part of my evidence of those who attended the class. Because I have to go and make sure that the attendance register is well marked. Good. The attendance register is well marked. So it's very important. We are able to look at that. So the next solid I want us to look at is a solid which is called a prism. Okay, a prism. As you can see, the shapes B and C, all of them are prisms. So as these two, B and C, are prisms. And in the definition of a prism has to have identical edges. That is, each and every edge. So a prism is a solid subject with identical edges. Mwisho yake lazima ikue inafanana. So the edges, they have to be identical. Now, the other thing is the faces have to be flat. There are no areas which are risen. No, everything is smooth. Everything is flat. And the same cross section all along its length. That's why we say we are finding the surface area and the volume of regular solids. So a prism needs to have all these three characteristics for it to become a regular prism. Now, in this other definition here, you can see a prism is a three-dimensional shape with two identical shapes facing each other. These identical shapes are called the bases. The bases can be triangle, square, rectangle, or other polygon. Remember, a polygon is a many-sided figure. The other faces of the prism are parallelograms or rectangles. So it can be a triangle, a square, a parallelogram, a rectangle, whatever it is. So I will now bring you back to these shapes that we have here so that we can see. This shape here, B, we have the shape B and we have the shape A. So this one is the head. This shape here, as you can see, how many sides does this have? 1, 2, 3, 4, 5, and 6. It has 6 sides. So a 6-sided polygon is called a hexagon. So we can say it is a hexagonal prism. Now let us look at C. We have 1, 2, 3, 4, 5. The end here has 5 sides. So we can see here we have a hexagonal, yeah, and we have a pentagonal. So we can see here we have hexagonal, prism, and then the other one, the 5-sided figure is a pentagonal. Prism. So hexagonal prism, it has how many sides? 6 sides. Pentagonal prism has how many sides? 5 sides. So it has it's 5-sided, yeah. So it is 5 sided. So this is what we are looking at. So we have a hexagonal prism, 6 sides, pentagonal prism, which is 5 sided, which is 5-sided. So how do we find the surface area of these prisms? Now, surface area, it means that every face of these prisms that can be seen is what we are going to be finding. For example, you can see here, we have here below here, we have been given measurements for the same, okay? Let's see, in B, we are told that radius is equal to 6 centimeters. Theta, you can see the angle theta here. So radius is the distance from here to here. That's what we call the radius. This is what we call the radius. So I'll draw it for you on the whiteboard, and then I'll see. Let me see whether I can be able to very quickly draw it on the whiteboard. Yeah, let me clear here. Whiteboard. So I want to draw. I want to draw. Yeah. We have this. We have this. We have this. Then finally we have this. So it's going to look something like that. I have not drawn it properly. So actually, let me just instead of drawing it here, let me draw it here. I think it's going to be to bring a better shape when I draw it here. A shape. Let me find whether I can see the shape here. 1, 2, 3, 4, 5, 6, 7. This one is not a. This one is a octagon. This one is 8-sided. So I was finding the 6-sided one. This one is not 6-sided. Why am I not getting the 6-sided one? Here. 1, 2, 3, 4, 5, 6. So this is the shape that I wanted. So this is a 6-sided shape that I wanted. Let me make it bigger. Yes. Yeah. So I am going also to insert something here. So let me see if I can insert something else, like a line. Someone is making noise. I've muted them. So I wanted to insert a shape here. A shape. Yes. I also have this one here. And these ones are supposed to be yellow. Shape. It's supposed to be like this. Yeah. So this is what I have done. And now comparing it with what I have here, I think it's not comparing it with what we have here. So this is the shape. This is the hexagonal shape I'm trying to do. So I'm trying to look at theta. I want to show you where theta is. That's why I was doing. I have been doing all that. So theta is this angle here. Theta. So this distance here becomes the radius, and this one becomes the radius, and then we have the angle theta here. So as you can see, whatever this one is giving us the shape. So you can see we have 1, 2, 3, 4, 5, 6. We said if we divide, remember we said previously last semester, if you divide a hexagon into triangles, it is going to give you 6 triangles. So so if I draw a triangle here, so this here is going to be the radius. This distance here is going to be the radius. Then this one is going to be the radius, and then this one here is going to be theta. Let me just highlight it for you so that you can see properly. So this one here is going to be the radius. Okay. This one here is going to be the radius, and then the angle here at the center is going to be theta. The angle at the center here is going to be theta. So remember, so the formula we are going to use here is the formula of a half AB to find the area of a rectangle. So I'm going to have a half AB sine of C. I have AB sine of C. I have AB sine of C. In this one, so it means we require two distances here. This distance and that distance. And then we have the angle beta here. So if we go back to our diagram, what we are going to see here is we have been told that radius is equals to 6. Theta is going to be 60 degrees. Theta is going to be 60 degrees. So we have here, we can say here it is a half, times AC, A is going to be 6, and also B is going to be 6 centimeters, times now the sine of 60 degrees, the sine of 60 degrees. Let me see if I have degree here. Caroline and your friend, please remember to give us our answers that we asked, so that we can check our progress. So I'm looking for the symbol of degrees. So 60 degrees. I have 60 degrees here. So the sine of 60 degrees. So a half times 6 times 6 times the sine of 60 degrees. So I will come here and share the calculator. A half is 0.5. 0.5 multiplied by 6 square, because it's 6 times 6, multiplied by the sine of 60, the sine of 60 degrees. And then I say equals, and you can see my answer here is what? 10/8. Now let me first of all find the sine of 60 degrees so that we can confirm the sine of 60 degrees is equal to, oh sorry, I think I did not write it well. In this calculator you write 60 sine. Oh yeah, I think this is the correct thing. So times a half, which is 0.5, times 6 squared, and then our answer is supposed to be our answer here. So we share another screen here. Say equals, sorry, equals. So this is the answer. 15.588. So we remove these others so that we are left with we only want to be left with the number of figures that we want. So 15, 1 significant, 5 significant, 5 significant, 8 significant. We consider the other figure because it is more than 5. So it is going to make this one 9. And then we can have centimeters squared. Now remember, what we have found here is simply the area of one triangle. How many triangles are here? 6. How many triangles are here? 6. So there's one here. We are going to come and multiply it by 6 to see the answer. And the answer is going to be 15.59. We multiply by 6. So I'll bring it to the calculator. Here. 15.59, 15.59 multiplied by 6. And the answer is 93.5. Yeah, 93.54. Is 93.54 centimeters squared. That is the face of only this part. Now, how many hexagonal parts do we have? Remember, there are two. There are two parts. So let me take you back to our figure here. You can see there is this part na kuna ile ya kule mwisho. Okay, so there is this part here and there is this other part here. So we are again going to multiply this one by 2. Yeah, because we have only found one hexagonal face. So I come back here to the calculator and then I multiply this one by 2. So it gives me 187.08. 187.08. Yeah. So this one again times 2 times 2. We have seen this 187.08. Yeah, 87.08. Yeah, centimeters squared. I'm hoping that I've already written the correct thing. 187.08. 187.08. Now, then we have been told L, this distance here, the length of the prism here, we have been told is 15 centimeters. It is 15 centimeters. Now, I want us to I want to take you back to this shape so that you can see, because as you can see, the remaining parts are rectangular. All of them, they are rectangular. So I want to take you back to our this shape here, and then we can see. And then we can see. So what I require here is to insert this shape, a rectangular shape. But then I'm not going to insert it here. I'm going to insert it. I don't know whether I can be able to do it very fast. Sorry. Good. So that is how it looks like. Yeah. I copy, I put another one here. I rotated this one. I'm supposed to come, actually I'm supposed to rotate it the other way around. So this one is supposed also to come and fit here. So I am supposed to come and fit it here. I think you can understand now. I come and fit another one here. So all these ones, all these other shapes here, they are going to be rectangles. And how many are they going to be? One here, one on top here, one on this side, one on this side, one below, and one on the side. So they are going to be 1, 2, 3, 4, 5, 6. So there are 6 rectangular shapes. And as you can see here, you have been given the length as 15 centimeters. We have been given the length as 15 centimeters. So we have the length. What about the width of this rectangle here? So I am going to come and show you how to find the width of the rectangle because we have the length. So I'm going to take my rectangle here, and then I now put it properly because we have seen only it's a rectangle. That's only that shape yake. It has been tilted a bit. So the length is 16. What about this? So this one is going to be this distance. There's going to be the distance of our shape here. Sorry. Move this one. So there's going to be this distance here. This one is now going to be there. So we have the length, and now we are looking at the width of our rectangle. The width of our rectangle is this distance here, the same as that distance there, that distance there, that distance there, that distance there. So remember what we said about this linear of ours? We said in this one it was 60. Okay, this is 60. So in a rectangle, if this angle here we say is 60, so this one it makes, and this distance was the same as this one because this one is the radius and the other one was the radius. Let's start some shapes here. That one, and then this one. So this, it means that these are the equality signs, okay? So that means this one now becomes an isosceles triangle. If this angle here is 60, so, and the angles in a triangle, they add up to 180. So you're going to say 180 minus 60. So I'm going to say 180 minus 60. I get the answer is 120. And then because there are two, I divide them by 2. And then I'm going to get that these angles are also 60 degrees. So it is not even an isosceles triangle. It continues becoming an equilateral triangle. So all the sides are equal here. Let me add this one. And then I make it this. So it is an equilateral triangle. So that means all the sides are equal. So if all the sides are equal, let us come back to our shape and see. Yeah, we were told that the radius was 6. If the radius was 6, so that means it is 6 throughout. It is 6 throughout. So it means this one is 6 centimeters, 6 centimeters, 6 centimeters, 6 centimeters, 6 centimeters, and 6 centimeters. Whatever I'm just doing is this. I'm saying this distance is 6 centimeters. Yes. This distance here is also 6 centimeters. Yes. And even this distance here is also 6 centimeters. And even this one is 6 centimeters. And even this other one here is 6 centimeters. So it is 6 centimeters all through. So that means if you remember, if this is 6 centimeters, remember this one and already put it here. So that means this one is 6 centimeters, and the length we were told in our original figure here, the length we are told is 15 centimeters. So what I have here is simply a triangle, a rectangle of 6 by 15. So to be able to find the surface area of the 6 rectangles, I am going to come here and say 6 I multiply by 15. That is for one triangle. How many triangles are they? 6. And what's going to be my answer? So I can come, I say 6 times 15 times 6. So if I go to my calculator, I'm going to get that. Yeah, 6 is squared times 15. Instead of saying 6 times 6, so the answer is 540. So I come here back to my enemy. So this one is 540 centimeters squared. Centimeters squared. Centimeters squared. So I have this. Yes, I have centimeters squared. Because they are 6. And remember, I also have 187.08. So what I'm going to come and do here is I will add, just put a plus sign, and then I add this. Okay. Then I paste. And that one now you can write, and then you can find its answer. You can now find the answer to that one, which I think is not going to be hard for you. So this is how you can find the surface area of a hexagonal prism that we have. That's how you can find the area of a hexagonal prism. So let's come to the other shape. Let's come to the other shape, and then I will now pause a bit. And remember, two friends there, there was an answer they were finding. So this is how we can be able to find that. That's the answer to that. Then we come now to this. This one is we see is a pentagonal prism because it has 5 sides. And as you can see here, this shape on top here, it is a rectangle with a right angle. It is making an angle of 90 degrees. So this one is a right angle here. It is just, it means E and D are not the same. You can see D is 4 centimeters and E is 3 centimeters. So in this scenario that we have here, it is not as uniform as the other hexagonal prism that you are looking at. So that means here we are going to have a right angled triangle. So we are going to have E and D. So I'll come here and insert a right angled triangle and then draw shape. Do I have a right angled triangle somewhere? Let me see. I'm just going to draw it instead of just having it already drawn. I'm just going to draw it, and then everything is going to be okay. Now this side that I've highlighted in yellow, it is the longest side in a right angled triangle. It's called the hypotenuse. It's called the hypotenuse. So as you can see in this shape that we have here, we consider E and D. We are only considering E and D. So I'm going to put the measurements E and D. E we have been told is 3 and D is 4. So that is the one that I'm interested in, 3 and 4. So this distance here, so you have 3 centimeters. And then we can now, sorry, not that. And then this distance here is 4 centimeters. So in a right angled triangle, because this angle here is a right angle here, the angle here, let me just try to highlight this. Yeah. So this one is a right angled triangle. So how do we find, how can we, for example, find the area of a right angled triangle? Or how can we find the hypotenuse? The hypotenuse, we say base squared, and then we add height squared, height squared. Is equals to hypotenuse squared. So in short, what we are saying here is 3 squared plus 4 squared is supposed to give us hypotenuse squared. So 3 squared is equals to 9, and 4 squared is equals to 16. So this one is going to give us 25. So if you find the square root of 25, you know that the square root of 25 So the square root of 25, we know very well it is 5. So it makes this side here, yeah, this side here, the hypotenuse is going to be 5 centimeters. So the hypotenuse there, as you can see, is 5 centimeters. Okay, the hypotenuse there is 5 centimeters. So if we come back here, we can now be able to see that if we find the area, we can now be able to find the area of this using half base times height. And then we have A and B. A and B is a rectangle here. A and B is a rectangle. So a rectangle, we just find the length and the width. So it is A and B, it is 4 times 5. And then we have a half base times 4 times 3. That's what you're going to do. 4 multiplied by 5. And then you add to a half base, multiply a half times 4 multiplied by a half times 4 multiplied by 3. So that one is divided by, we have said is a half. times, just do it fast because of time, times 3, and then you see times 4. A half times 3 times 4, which is going to be, this one is going to be a half times 3, is a half times 3 times 4, a half times 3 times 4, so this one is 2 times 3, is going to be 6 centimeters squared, 176.6 centimeters squared. And then you see plus A times B. A times B is 4 times 5, which is 20. Plus 4, plus into brackets, 4 times 5, which I'm very sure is 20, is equals to 20 centimeters squared. So we now add 6 centimeters squared plus 20 centimeters squared, and definitely we are going to have the answers 26 centimeters squared. So this, whatever we are doing now here is 26 centimeters, whatever you have gotten here is 26 centimeters squared. That is the face of the pentagon, the face of the five-sided figure. Do I have a pentagon here? No, I don't have a pentagon here. So I don't need to draw this pentagon. I think I have a pentagon here. Yes. So this is a pentagon. So this face only is the one that we have found is 26 centimeters squared. We come back here. So this shape is going to be repeated on the other side. So I multiply this pentagonal shape here times 2. So I come back to my working here, and then I share. So here I'm going to multiply this one by 2. By 2, 26 times 2. The answer is going to be 52 centimeters squared. 52 centimeters squared. That is the face of the pentagon, because the pentagons are two. That is this side, and we have the other side. I want to show you this. The other one is on that side. So now, what was happening here is you would join this. You would join this, and then you join here. Then you join here. Yes. So this is how a pentagon would look like. So this one was the 4 and the 3 centimeters. Okay. Yes. Yeah. So that is what we had. It is not. I know it might be a bit different, but this one, remember, this one is 3, not like the other one that we have here. Then we have C. This side C and the other side. So we have this side of C and the other side. They are going to be rectangles that are the same. So you have C times A. A is 4, C is 8. So you have 4 times 8, which is the 2, and then we multiply by 2 because of the one on this other side. So you have that 2 multiplied by 2 from here. So we have that 2 multiplied by 2, which is 64. So we come to our calculation part. So this one we add it to 64, and then we also add to, so we have 52. We put them here. And then I come back here. Yes, so I have the base takwani B times C B times C is what? 5 times 4, which is 80. 5 times 4 is going to be 80 centimeters. So you add 80. And then I add what? I add E times C. E is what? E is 3, C is 8. So this side of E is E times C, which is 3 times 8, 24. And then D times C. D times C is what? 8 times 4, 32. So 32 and 24. These are the new measurements that I will add here. 32 plus 24. So there we can now have the answer. So this 52 was because of the two pentagonal shapes. 64 these pentagonal shapes. Then we had the 64 was because of this side and the other side. And then we have the 32 and the 24. And then we have the base here, which we had already said is B times C, which was 40. So I think you have included all those measurements. So very quickly now you can come here. Do you have 40? Let me see. Where is 40? 52, 64. I think it's something that is not correct here. Let's correct it. C times A. We have not added the base. B times, oh yeah, B times C is 40. We have not added 40, sorry, we have not added 40. The area of the base, we are not adding that. So I think plus 40. Plus 40. Plus 40. Plus 40. So that is how you can now have the surface area of your pentagonal prism. The surface area of your pentagonal prism. The surface area of a pentagonal prism. Now a prism can take different shapes. As you can see, this one is a triangular prism because the cross section here or one end is a triangle. That's what we have. Let's look at another. Yes, this prism here actually is like the prism that we are finding 1, 2, 3, 4, 5. This one is a pentagonal prism. This one is a hexagonal prism. What we have here is a prism. Yeah, you can see 1, 2, 3, 4, 5, 6. Hexagonal prism. Yes, this one has 5 sides 1, 2, 3, 4, 5. And this end here, it is called the cross section. So now to find the volume of a prism is very easy. You say cross sectional area, and then you multiply by the height. By the height. Some people you are going to find them putting the length. That is how you find it, and then you get your answer in cubic units. You get your answer in cubic units. So we are just going to find the volume of this. Now this, so what was the area of it? So to find the volume of this prism here, we find the cross-sectional area, the area of this hexagon, and then we multiply by the length, which is 15 centimeters, okay? And for this one, we find the area of this whole pentagon, and then we multiply by the length, which is C, 8 centimeters. And we can be able to do this one. Like in this very last example that we had here, we can see that the cross section, we say the cross section was 52 centimeters. So we can say 52 centimeters, and then we can multiply by C. C is 8. So 52 centimeters, the area of this cross section, times 8. And then you have your answer in cubic centimeters. So, yeah, times 8. So 52 times 8. So for this one was 52 times 8. 4 is 52 And then we have times, then we have 8. So we are going to have our answer here. That is for the pentagonal prism. And then when we look at the hexagonal prism, let's come to the hexagonal prism here. Hexagonal prism. So as you can see, the cross section gave us an area of 93.54. So 93.54, we are going to be multiplying by this L here, as you can see the L here. So times 15. We are going to multiply it by 15. So 93.54. So no, so it was, yeah, it is one side, 93.54. I now multiplied it times 15. 93.54. I multiply it times 15. 93.54. I now multiply this one by 15. Then you're now able to find the volume of that prism. So, ladies and gentlemen, that is how you can find the volume and the surface area of a solid called a prism. We have said a prism is given its name from the shape of one edge, which is called the cross section. So we have seen a triangular prism. We have solved a hexagonal prism and a pentagonal prism. Look at the shapes. The shapes are either going to be they are going to be triangles, rectangles, and any other shapes that you're going to find there. That one you are able to find its area. Remember what we did last semester before we were interrupted by the corona break. So before we started this topic, that's what we were doing. So you follow those simple guidelines. So I will now come to the participants, and then I want us to have a small interactive session. So I'll be encouraging you to speak. Some people have been here. So let me go back to, now there were some, my friends. Where is Joyce Atieno? Joyce Atieno. Joyce? 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 Joyce, can you hear me? Did you give us the answer in the chat? Joyce, type that answer you are supposed to have. Joyce, type your answer. Joyce, are you giving us an answer? Jerry? Jerry? Jerry is not speaking to us. Jerry?
Yeah.
Jerry, are you there?
Yes, I am.
Also, you are getting us?
Yeah.
Do you have a question? There's a time your volume was not okay.
No, I don't have one.
Okay. Teresia, do you have a question? Yes?
No.
Let's come to Christine. Christine, now you are hearing us. Do you have a question?
Yes, I'm not hearing you. Sure.
What was wrong with your volume?
I don't know,
I think it was your settings.
but I've already.
I can see you have already sorted it. So, do you have any question?
What?
Do you have any question?
No, by the way, by the time I wasn't here. I knew. I was just following the way you were teaching,
Or
but
the steps?
for sure,
Yes. Yes.
yeah, I was just following the steps.
So, but you have understood
Some,
some of. So,
but
any question?
itabidi sana nikuje consultation, manake hizo nilikuwa nafuatilia, sijaelewa vizuri
Kama gani?
because I was.
Yes, like which one? Kristen?
Hello.
Yes.
Yes.
So which one did you understand? Which one did you not understand? Okay, so you see in the chat session, in the chat section,
Yeah.
please write your questions there, so I'll respond to them. Okay.
Okay.
Emma Buva. Buva,
Yes.
how are you?
Yes, sir.
So were you following us?
Yeah,
So any
but
question?
not from the start.
Any question
No.
that you have?
No.
Yeah. So yeah. So for each and everyone, let me just hear everyone speak. Come to Faith. Hi, Faith. How are you? How are you, Faith?
I'm fine.
Okay, so you are getting us? Faith? Are you getting us, Faith? Joyce Atieno. Joyce Atieno was supposed to give me an answer together with your friend who has disappeared. Do you still have the answer?
Yes.
So
84.
did you type it? Just type it, whatever I told you. So we are going to give the comments. Yeah. Thank you for finding the answer. Kevin Monene.
Hello.
Kevin, you're in a place where there's a lot of noise. So let me just mute you. You're in a place where I can hear the TV is on. Kangualela, you are joining us. You are disappearing, joining, disappearing, joining, disappearing. But I'm glad you are here. So have you gotten something? Kangualela? Please, Kangualela.
Yes, I have.
Yeah, you
It's-
have.
Yes.
Kangualela is your name?
Kungu Angela.
Oh, Kangu. Oh, sorry. I was reading.
Kungu Angela.
Kungu Angela.
Yes.
I can see you have joined us. Thank you for joining us. So have you gotten
Welcome.
something for the time you have joined us?
Yes.
Okay, that's good. Let's speak to Mogo. Evelyn. Mogo. Evelyn, do you copy? So you are getting us?
Yes,
You are
Yes.
you are getting us?
yes.
Any questions? Any question from me?
No, no.
I think I had spoken to Teresia. Teresia, I had spoken to you.
Yes.
We are. I had also spoken to Jerry. So I think I've spoken with everyone of you, which is a good thing. Yeah, for you people. Thank you. I can see you have typed here. Thank you for your answer. So what will be happening is if you have a question or you have 5 times square times 12. Yeah, so I can see also what the Jerry has also solved something here. So yes, where the The height was 12. The volume, I think this one is a question of volume because I can see this one is pi r h. Yes. So thank you for your answers. So if you have a question, you just type it at the chat. I will see it, and then I will get back to you. So I want us now to finish. Kialo is coming back again. Let us just admit her so that she can now join us for the last part of this session. Okay, so I come back here. Kialo has joined, but Kialo doesn't have the volume. So I don't know, she cannot hear me because I can see her volume is not there. So she has to do the volume settings. Kialo, you are going to do that because I've already shown you how to do it. So I now want to come back. Now let me just share these ones with you. This one is a prism, triangular prism. As you can see here, we have the cross section, which is the cross section. This one, which is a triangle. So this one is a net. Iko imefunguliwa. Okay. This one imefunguliwa, and here it is a net. So you can see the two triangles here. You can see the two rectangles, and then we have the base. We have the base. The base ni huku chini. So that is what we have. This one is another example of prism, a triangular prism. Yes, yeah, triangular prism. This one is a right angled. So this one is a right angle. This one is a right angled triangle prism. So it is a prism. It's a triangular prism, but you can see the cross section here is a right angle. We already talked about the cylinder. So now we go to the other shape, which is a cone. Let me just talk about a cone before I come to the cylinder. Yes, cone. So this one here, we call it a cone. Cone. It is conical in shape. It's conical in shape. So this is a cone. This here is a cone. So a cone, it has a base, and this sharp pointed part here is called an apex. And then we have this end here, it is called the slant edge. The slant edge. I don't know whether I can put some, I can design another cone here so that you can see me drawing it. I want to design a cone. So I insert a cone. A cone is going to be circular, and then we're going to have everything else. Let me see. So this one is conical shape. This one. So what I can do here, I can insert the circular part so that you can just see it. So a cone is going to be formed by, if this one is like having a net of a cone. So I'm going to have two shapes, a circular part, and then I have the curved surface area. If you look at this diagram here, this one, you can see the circular part, this is a circular part, and then this is a curved surface area. So this distance here, we call it the, let me just draw it. This distance here, not that one, supposed to be here. Let me just repeat it. I'm going to repeat it this way. So this distance here that you can see I've already highlighted, this is what we call the slant height. We have two slant heights. Let me show you the other slant height. So it is here. So this is the other slant height. So these two are the slant heights. Now remember there's distance here. You can see the one I'm following here is the slant height, and this one is the slant height. Now this one is the actual height. Slant height, it is always not the same as the height, because height is perpendicular with the base. As you can see here, this is a base, and from here to here we have the radius, okay? So this height is perpendicular to the base, but this one, we call it the slant height, and it is abbreviated as L, with a small l. It's not supposed to be capital letters, L. It's supposed to be abbreviated as L. Yes, abbreviated as L. Okay, so it's abbreviated as a small l. So you have the circular part. This one is not a triangle because you can see it is curved. So it's not a triangle. Only here I've not drawn it in 3 dimension. Okay, this curved part here, is the curved surface area. So in a cone, we have 2 things. We have the curved surface area. And then we have the circular part. We have the circular part. Let me increase the font so that you can see this. Plus the circular parts. Okay, so obviously the circular part, I'm going to show you the circular part. You know, we use pi r squared. Okay, pi radius, pi r squared, the circular part. That one is easy. So plus, in the curved surface area, we use this formula, pi r l. L is the slant height. So you use pi, you multiply by radius, you multiply by the slant height. So I want us to look at one example, and then we can solve that, the example of a cone. So let me see. This one, not this one exactly. Let me come here. Let me share. Sorry, let me share this video. I was here. Not that one. So I just want to see something here. Just bear with me a moment. So let's share a Word document. So let's come up with our cone here. Let's say the radius of the cone is equals to 7 centimeters, and the height of the cone is equals to 12 centimeters. So find the surface area of this cone. Radius of the cone 7 centimeters, height 12 centimeters. Now I want to draw a right angled triangle so that you can see how that figure is going to look like. So this here, as you can see here, is the height, which is 12 centimeters. Let me come and make it smaller. Okay. Then we come here below, and then we have the radius as 7 centimeters. So if the radius is 7 centimeters, it means you can be able to find the area of the circular part. Someone is making noise. Nani huyu? Kongo Angela. Yes, he is now muted, so we can now proceed. Yeah, so if the radius is 7 centimeters, then we can be able to find this part here. We can be able to solve this part here. By putting brackets and saying pi is, we are going to use pi. So we say pi times, pi times radius is 7, and then you say times 7 again. Okay. So pi times 7 times 7, and the answer is going to be, where is calculator? So in the calculator, we are going to have pi times 7 squared. That's going to give us the answer as 153.9, because it is in 4 significant figures. Let's come here, 153.9. And the answer here is 153.9 centimeters squared. Centimeters squared. That one is, there's no problem in that. But this other part of the pi RL, let me just enter, do it here, pi RL. So we are going to have the pi, basically, we insert our pi here, pi times radius, which is 7, times slant height. We don't have the slant height. But remember, I told you here, in this one, let me just bring it here so that you can see it. We said the height was 12, and the radius was, delete this one. Delete all these ones, they are not important for now. Let me insert something here. So this text box here is a text box I've inserted here. So the height is 12 centimeters. So let me bring it here so that you can see this. centimeters, and then I can copy it, copy and paste here. And then this one is 7 centimeters. So that means I have to use Pythagoras theorem to find the slant height. This one here is the hypotenuse, or the L stroke height, the hypotenuse. So this is L stroke the hypotenuse. So let me remove the hypotenuse so that we are left with L. So this one is the slant height here. The slant height. So in many scenarios, somebody or the examiner is not going to give you the L. The examiner will expect you to calculate the L. So how are you going to find the L? By saying, because this one is a right-angled triangle, 12 squared plus 7 squared is equals to L squared. So this is what you are going to have here. Let's do it here. 12 squared plus 7 squared is equals to L squared. Let me now format these ones. These ones are now supposed to be squared like that. Yeah, so this is what we have now as a formula, L squared. So 12 squared is equals to, that one I know is 144. You have your calculators, please. Then we have 7 squared is 49, which is equals to that one. So you have 144 plus 49, and then we get L squared, 144 plus 49, 144 plus 49. So I've not done the correct thing here. 144 plus 49 is equals to 193. So 193. So we can say L squared is equals to 193. So L squared is equals to 193. So to find L, we have to find the square root of 193. You have to find the square root of 193. So the same as doing this. Square root of 193. So the square root of 193 is this. Is 13.89. centimeters. Kuna mtu anaongea hapa. It's okay. So we have 13.89. 13.89. So the L here now can now come here to L. We now say L is equals to 13.89. And so we can come to back to our formula. of pi pi times r times l. So pi times 7 times, you can now come here and put comfortably 13.89. 13.89. And the answer there is going to be 13.89 times 7. 7 times 5 times 13.89. And the answer is, in four significant figures. Let me copy the all of these down just so that you can see how we are going to write it in four significant figures. The answer is going to be big, large, obviously. So you can see the answer is very big. So we require only, not all of them actually. That require. So these are 1, 2, 3, 4, 5. So that's one for 7. So I consider the very significant figure, which is 5. So it rounds off, it is already 5. So it rounds off the 4 to 5. So the answer now is 0.5 centimeters squared, because this one is area. Centimeters squared. So this is now whatever we call the curved surface area. This so that one is the curved surface area now. So to find the surface area of a cone, you have the curved surface area plus the area of the circular bottom. The area of the circle is pi r squared, which we got as 153.9 centimeters squared. Pi rl is the curved surface area, which is 305. So pi times r times l. What we did here, we did not have an L. So we had the radius and we had the height. And because you know they meet perpendicularly, it makes it a right angled triangle. So you can be able to calculate the L, which is the L or the slant height, which is found by Pythagoras theory as 13.89. So you are able now to come here and substitute this one to get the correct answer. So that is how you find the surface area of a cone, by saying pi r squared plus pi r l. Pi r squared plus pi r l. So let me make it small for you so that you can now do. Now let's find the volume of a cone. The volume of a cone is found by this formula here. That base area times the height. That base area times the height. That base area times the height. What is the base area? The base is a circle. So the formula now changes to that. We have said the area of the base is a circle. How do you find the area of a circle? Pi r squared. So pi times radius squared and then times the height. So it is a that pi r squared h. So we can now remove times because it means the same thing. So it is a that pi r h. That is how you find the. That's how you find the volume of a cone. So it is a that times pi. Our radius is 7 and our height is 12. So it's a that 1/3. You now multiply by pi You also multiply by 7 squared, and then you multiply by 12. So you know that it is times, and then you multiply by 12. Multiply by 12. This one is 7 squared, not 72. This one is something is wrong with my mouse here. That's how you're supposed to get the answer. And then we give our answer because it was centimeters in cubic centimeters. That answer there, you can solve it at home, and then you can have the answer. So we have a that times pi times 7 squared times 12, which is a third base area. Remember, it's a third base area. A third base area times the height. The base of a cone is a circle. So that's why we are saying a third pi r squared. And then you multiply by the height. And then you multiply by the height. So let us look at one example of volume here. I think I have and several of them. I don't know if it has one. That one. Okay, let me see what the example is, and then I'll try to retrieve it. So we are let's calculate this surface area and then the volume. So calculate the surface area of a solid cone radius 7 centimeters, height, the original height 13 centimeters. So you are going to find the number one, you are going to calculate the surface area. And then number two, you're going to find the volume. So surface area, we say it is found by, the base is a cone. So you start by pi. Someone is making some noise there. I think it's a background noise. Pi r squared. And then here is the plus. Pi r l. That's how you're going to do. Now, as you can see here, we don't have an L in this case because pi r squared is going to be very easy. Because pi r squared is going to be pi times radius is 7 squared. I think Mogo Evelyn is making some noise. Let me mute her there. Good. Yes. And then you can now see plus pi Insert our pi here. Pi, and then we multiply times r, radius is 7. L, we don't have the L. So we first of all calculate the L. Okay. So let me take these ones back. Radius is 7. Let me just use this one to calculate it. Radius is 7, so this one now becomes 13 centimeter. So definitely this one is going to change. So it is 7 squared. So you are going to use, say, 13 squared plus 7 squared is equals to 12 squared. 13 squared is what? 169 or what? I think so. 13 squared is 169 plus 49. I don't know what that answer is. Let me come here. 13 squared plus 7 squared is equals to 218. So the square root of 218, because that is L squared now, so you have to find L. So the square root of 218 is going to be like this. Square root of 218 is 14.76. 14.76. 14.76. That is what we have here, 14.76. So here we can say pi RL, we can now comfortably say L is 14.76. So that is how you can get the answer. Pi R squared plus pi R L. That's how you can get the surface area of a cone with these dimensions. What about the volume? The volume we said is a third. Let me just copy the formula here. So that we can amend it here. We said it's a third pi r squared h, so it is a third times pi times 7, but then the height now is 13. So the answer is going to be different. A third pi r squared h, because it is a third, remember what I said is a third base area times the height. The base of a cone is a circle, and the volume, the formula of finding the volume of a circle is pi r squared. So that is what you have. So basically, that is how you find the surface area of a cone. So next lesson, we are going to find the surface area of this shape. This is a lamp, it's called a lamp shape. This one is a bucket, and there is the shape of something called this. It's called a frustum. A frustum is cut from a cone. As you can see, if you elongate this, you're going to get a cone. So we are in the next lesson, we are going to find the surface area and the volume of a frustum, and then a sphere, and then finally a hemisphere or a half of a sphere. That is what we are going to be doing next week. So, ladies and gentlemen, I can see Kelwa is back here again. So maybe we can come to chat, and then we can write a few messages on the chat. Joyce Otieno, yes, I can see Joyce has written a formula here. So you can ask questions, please. Joyce, thank you for your formula. Owande, also I can see you wrote your formula there. Caro got lost. Caro, please, can you type your formula to us. Please type your formula to us, Carol. Carol, can you type the formula hapa kwa chat? Carol was doing a certain question. That's why I'm asking you, or that's why I'm asking her to give us the answer. Carol was doing a certain question. Carol, you're waiting for you. Carol? Oh, Jerry is asking, is 7 radius or base? 7 is the radius of the base because the radius is of the circle. In a cone, the base is circular. So 7 is the radius of the circle or the radius of the base. The shape of the base of a cone is a circle. That's why we are saying 7 is the radius of the base. Okay, Jerry. You can see Carol has said 2 times 22 over 7 times 3 squared times 12. 2 pi r squared h. Yes, that's the correct formula. Thank you for doing that. So everybody else, the likes of Christine, the others, please, the others, can you write your messages here as we wind up the lesson? Write your messages here as I get some water so that. Write your messages. Write your messages here, please. Just a moment.
Good morning, class. Munene. 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 Christine. Kangu.
Yes,
Kangu.
so here I am. I cannot see any messages here. What is happening? Messages. Kongo, Angela, and Mogo Evelyn, you cannot see your faces. Emma Mbuva and Christine, you cannot see your faces. There's a place in the screen where you display your face so that you can be able to see you. At least so that you can know you are here. Joyce Atieno amepotea. Teresia Wamboi, Emma Mbuva, Christine, Kongo Angela, Mogo Evelyn. Please, can you see your faces? Show us your faces so that